Hello, my name is Kupiran and I'll describe the transmission line that is in Malaysia. So, a transmission line in Malaysia is actually a power distribution backbone to all the facilities that needs electric generators, powers to power up the facilities that's in the certain area. So, the high voltage efficiency is important. It operates at a high voltage, allowing more of the efficient energy transfer through a long distance, which then reduces the energy loss during the transmission. The long distance energy transportation, where their primary function is to transport large quantities of electric over extensive distance, connecting power plants to vigorous regions and meeting the energy demands for a distant community. In terms of grid interconnection, transmission lines are interconnected different parts of the electrical grid, ensuring a reliable interconnected power supply across the cities, states, and even countries. This interconnection system is also known as the system of interconnected elements, in which complex networks of transmission lines. Transmission line consists of complex network of interconnection elements. Each component is designed to meet regulatory and technological criteria considering structural integration and load bearing capacity and electrical performance. Adherence to regulatory norms ensures safety, dependability, and compliance in the power section. In Malaysia, we also have transmission towers. Transmission towers in Malaysia is a diverse gearbox tower structures in Malaysia. Common gearbox tower structure in Malaysia includes lattice steel towers and monopoles, which the lattice steel towers uses angles and plates, which monopoles are single tubular plates with welded arms. The material and composition grades are also involved in this criteria. Materials and construction techniques used is when the gearbox towers are being built in Malaysia, it uses high tensile and mild steel grades for constructions. High tensile steel is chosen for its strength and longevity. Hot dip galvanizing coating steel with zinc provides corrosion protection, ensuring durability in various environmental conditions such as rain and also the weather that might corrode the steel. So we need all this to improvise our towers in Malaysia. Based on the project line that is in Chuping to Kayu Hitam, it's about a 35-kilometer project. So we need at least a lot of materials in order to have a successful power line project. Is crucial to raise population and businesses in the area. Economy benefits include boosting development, at which also attract investment in case if there's going to be a factory that's going to be developing there, and also securing a power supply, sustained power supply to the nearby villages and provide them with stable connectivity of a power grid. Last but not least, beyond electrical transmission, this is important for the economic growth and community well-being. It's then by doing this, it improves power supply stability, ensures business remain operational, leading to job securities and community improvements in that area. By doing so, it reduces the cost to minimize losses and outages, because from the tax that they get from the company and also the villages nearby, by providing them proper power supply, they can maintain a good well growth for their revenue. That's all. Thank you.
Hello Puan, my name is Sham Sridhar. Today I am going to discuss the management organization of this three-phase transmission line. The project director is Mr. Manoj. He is overall responsible for the planning, execution and completion of this transmission line project. Mr. Manoj manages the project scope, schedule and budget. He also acts as the primary point of contact for stakeholders. The quality control manager is Mr. Azwa. He oversees the quality control processes for the project. He carries out monitoring and ensures the quality of construction work and materials, and he also collaborates with the construction manager and engineering manager. Next in line is myself as an engineering team manager. I oversee the engineering and design aspect of the transmission line project. My tasks include coordinating with the design team to ensure technical requirements are met, managing the engineering team, and interacting with the project manager. Moreover, there is a construction manager, Mr. Ben, who oversees the construction phase of the project. He manages construction activities, schedule, budget, and ensure compliance with safety and quality standards. Further, The procurement manager for this project is Mr. Haikal. He is responsible for procuring materials and service needed for this project. Mr. Haikal develops procurement strategies and manages vendor relationship. He also ensures the timely delivery of material and adherence to budget constraints. Finally, the site supervisor is Mr. Kuhan. He manages day-to-day construction activities on site. His task is to coordinate with the construction manager to ensure work aligned with project plan. He also report progress and issues to the construction manager. Next, I'm going to discuss the work breakdown structure. A work breakdown structure is a hierarchical outline of the task required to complete a project. The WBS breaks down the structure of a project into manageable deliverables. Each deliverable is assigned a task or series of tasks that can be further broken down into subtasks to meet the need of the project. First of all is the project planning and management by Mr. Ben. The tasks under this are project charter, project scope, management, project schedule, project budget, and project risk management. Next is site surveying and analysis by Mr. Kuhan. He carries out tasks such as site selection, topographic survey, environmental impact analysis, and soil analysis. Furthermore, this project has design and engineering by me. Under it are the tasks such as transmission line design, tower design, foundation design, and electrical design. Moreover, we also have procurement and material management by Mr. Haikal. Task includes material sourcing, equipment procurement, and inventory management. Mr. Ben also takes responsibility for construction. This covers access road construction, tower erection, conductor stringing, transformer installation, and substation installation. Mr. Azwa, on the other side, takes over testing and commissioning. His tasks are electrical testing and system commissioning. Finally, our project director, which is Mr. Manoj, does the project closeout. He does the final decision, punch list, as build drawing, and warranty and maintenance. Thank you.
Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Zarfan Asfar bin Ashar. My metric number is 211361420. Today, I would like to discuss about our mini project, which is a transmission line from Chopin Perlis to Bukit Kayu Hitam, Kedah. So, my part is to plan and schedule project of transmission line by drawing the project network diagram. So as you can see, the table 1 shows the sequence of activity for the transmission line project. So from the task, we have a lot of activity here, which is A, B, C, D, E, F, G, H, I, J, K, L, M, N, and P. So the expected time duration, which is week, has been given, and the interrelationship also have been given. So from this information that I get, I can make the schedule activity for the transmission line project, which is we can see to make a transmission line project. We can see the predecessor from A, B, C, D. The predecessor is A, E, C, F, B, C, and D, G, C, and E, I, H, J, F, and G, K, J, L, F, and G, M, L, N, I, K, M, and P, N. So the beginning and ending event was calculated after I finished construct the transmission line network. So the optimistic event, which is TO, and most likely event, which is TM, and pessimistic event, which is TP, we just assume, just six the information we just assume, and expected time has been given. So all the information here can be calculated the critical path, which is my friend Haikal Michael can explain that later. So from, from that information, I can make a line transmission here, which is we can see from activity 1, activity A, we can see from 1 to 2, and 2 to 3 is activity B. From 2 to 4 is activity C. From 2 to 5 is D, activity D. So activity 6 is from 4 to 6. I'm sorry, activity E from 4 to 6, and activity F from 3, 4, and 5. So we make a dummy, which is we have two dummy between 3 and 4, and 4 and 5. So we get F. So activity G from 6 to 7, activity J from 7 to 8, activity L from 7 to 9, activity H from 7 to 10, activity K from 8 to 11, activity M from 9 to 11, activity N from 11 to 12, and activity P from 12 to 13. So all of the activity here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 network line, transmission line here. So from this transmission line, we can conclude that we have 13 information here. So that's all from me. Thank you.
Assalamualaikum and hi. My name is Muhammad Haikal bin Anwar, number 211361415. First, I will explain about my job scope, which is as a procurement manager. In the mini project about the transmission line, the procurement manager played a crucial role in ensuring the successful procurement of material and services, responsible for procuring materials and services needed for the project. The procurement manager develops procurement strategies and manage vendors' relationship to optimize cost, saving, and efficiency. This involves reviewing project requirements, requesting quotes from vendors, negotiating prices, and selecting vendor based on quality, cost, and delivery timeline. Additionally, the procurement manager establish and maintain positive relationship with the vendors, communicate project requirement and expectation, and address any issues that may arise during the procurement process. Furthermore, the procurement manager monitors vendor performance to ensure timely delivery of materials and services, tracks project expense to adhere to budget constraints, and provide updates to the project management team on procurement progress and budget status, ultimately ensuring the project success. Okay, next I will continue with my task, which is I need to identify the critical path for my project of transmission line and evaluate the expected time, which is need to be complete in 99.85%. So here I have to do the calculation of expected time and standard deviation. So for the expected time, here is the formula. Here is the formula, which is optimistic time plus 4 times with the most likely event plus with the pessimistic event over 6. And I will get the value here for every activity from A to P. The next is the variant. The variant formula, which is pessimistic event minus with optimistic event over 6, and I will get all this value for the arrays for all of the activity. Okay, next, as you can see, here is the network diagram for the critical path. I already do the calculation. As you can see here, I get the critical path is A, C, E, G, L, F, N, and P. So here is A, C, E, G, L, M, N, and P. So from this, we can find our cumulative expected time. The cumulative expected time is actually the critical path expected time. Here is A, C, E, G, L, M, N, and P. So we need to add overall and we will get 75 weeks. We can also find the event standard deviation here. So for the formula of the event standard deviation, we need to square the critical path variance and need to square root all. So we sum up all of this and we will get 3.21. So from two of these, we finally can find our completion time from the question that we need to clarify, which is the question give 99.85%. So from this, we will convert to 0.9985, and from the 0.9985 here, we will look at the distribution table and get the corresponding value, which is we get 2.6, 2.96 here. So from 2.96 here, we can actually find the completion time that we need to accomplish, which is the formula is 75 week plus the corresponding value 2.96 time with the event standard deviation here 3.21, and we will get 84.5 weeks or approximately 85 weeks of completion. This is uh, the probability that we get, which is 84.5 weeks or 85 weeks for complete this project management. So that's all for me. I will pass it to other member.
My name is Manoj, son of Subramaniam. My metric number is 221361412. I am going to present about 4.5, which is project cost estimated of transmission line. For the project, the length of transmission line is 35 kilometer, which is equivalent to 335,000 meter. So distance between each tower is 250 meters. So equivalent to each number of tower needed for this project is 140 towers. Alright, now we're going to talk about the tower. Each tower has 4 legs. So for this project we will use 140 towers. So each tower got 4 legs. 140 times 4 legs equal to 560 holes. So each hole is 4 feet wide and about 30 feet deep with slight projection above the ground. So cubic foot is 4 times 4 times 30 equal to 480 feet per cube. And total volume of concrete needed is number of holes 560 holes, and volume of concrete per hole is 13.584 meter cube. Thus the project needed is 560 times 13.584, 7607.04 meter cube. Rounding off will be 8000 meter per cube. Now I'm going to talk about cost of ready mix concrete. For this project we're going to use 8 items which I listed here, and the total cost for 140 items will be listed down here. And for the cost of acids, we're going to use 3 items, and the price list was here. And now we're going to go for the cost of materials. We're going to use transmission towers, ready mix concrete, conductor 250 meters, and ground wire 250 meters, and insulators stringing shifts, vibration dampers, and weights, suspension, and dead and hover. Here is the unit cost and per unit, and total amount for cost of material will be 222,130,800 ringgit. Okay, now I'm going to talk about cost of subcontractors and consultants. So the contractors we need 72,000 and subcontractors we will spend 72,000 also, and for the consultants we will be using 42,000. And for the fourth, we're going to list down the cost of labors. Discussion with list down here, which I'm going to use list down as per skilled, semi-skilled, and unskilled. And this is the unit cost, and this is per unit we needed. And total cost of amount was list down here. And for the fifth was cost of overhead. For the two words description, fuel and transportation and shipping, the cost will cost us 15,000. And for the second, utility and electric bill and water, which was cost us 7,000, sorry. And for the grand total cost of all categories will be description per list will be 5, which was asset, materials, subcontractors, and consultants. And for the fourth was labors, and fifth is overhead. The cost was lifted down from for the as per on the table, which is 29,000, 222,130,800 ringgit, and 186,000 and 140,000 and 222,000 for overhead. And that is for all the include for the cost of estimation of the project. Thank you.
Hello, my name is Kuhanwira A. Ramesh, metric number 211361411. Now I will be presenting 4.6 cash flow diagram. So as you can see, this is the cash flow diagram for this project. The initial asset value or the initial purchase value of the crane is 158,000. The resale value is 2/3 of the value. Therefore, the value is 105,333 ringgit. That's why the arrow is pointing towards 105,333. The asset age and is 84.5, which is 85 weeks or nearing 21 months or 2 years. Therefore, the depreciation value is 158,000 minus 105,333.33 ringgit divided by 2 years. Therefore, the value is 26,333 ringgit and 34 cents. For the first 2 years, the depreciation value is there. Next, the total depreciation up to year 1. The first one is 26.33. Then next, the cumulative value. So therefore, after plussing both, we will get 52,666.68 ringgit. Next, for the book value at the end of the year. So what we will do, 158,000 minus with the first value in the total depreciation here, which is 26,333.34 ringgit. Therefore, the value is 131,666.66 ringgit. Next, for the final one, 158,000 minus 52,666.68 ringgit. Therefore, the value is 105,333.32 ringgit. So that's for the depreciation of the value. Next, as you can see, this is the graph plotted in MATLAB. The depreciation, which is the red line, is constant. The total depreciation, the green dotted lines, increases, and the book value, the blue line, it decreases. So finally, for conclusion. In conclusion, this assignment has enabled us to explore cost-effective and environmentally friendly methods for energy transmission. We've also learned to manage the planning, scheduling, and cost of transmission line project, specifically for a 35-kilometer line in Malaysia. Through this process, we gain a deeper understanding of how to control and evaluate these projects as we strive to meet the growing energy needs in a sustainable manner. This assignment also gave us knowledge that will be invaluable in future endeavors in electrical energy. Finally, this assignment also prepared us for our future advancements in the field of energy transmission. That's all from me. Thank you.